Hello, my name is David Black, and I teach here at Walden School of Liberal Arts in Provo, Utah. I'd like to introduce you to an activity that teaches students about the scale and proportion of the Milky Way galaxy. In this activity, students will build a three-dimensional model of the nearby stars out to 15 light years from our solar system. In the process, they'll learn about the coordinate system astronomers use to locate an object in three-dimensional space. They'll learn the distribution and abundance of different types of stars in our neighborhood, and whether they are single, binary, or trinary star systems. They'll also learn about recently discovered brown dwarfs and exoplanets. This activity also gives students a practical example of how to use trigonometry to locate the correct positions of the stars in our model. You need to begin with a platform, which will hang from your ceiling. Now what you're seeing here is the underside of the platform. I've marked this off in concentric circles every 5 centimeters, representing that 1 light year equals 5 centimeters on the scale of our model. The radial spokes on this model represent the right ascension lines. I'm beginning here with the vernal equinox at 0 hours, minutes, and seconds. They're being marked off clockwise on the underside of the platform. So what you're seeing then is a vernal equinox, summer solstice, autumnal equinox, and winter solstice. And these represent the right ascension or the celestial longitude of your model. Now you'll notice that this platform has been built out of 6 sheets of foam core. I've got it set up so that they're taped together, but I can cut the tape and then store it pretty easily from year to year. Now to stiffen up the platform, on the top side I've also put pieces of PVC pipe and cardboard tubes across the pieces of foam core. At each corner I have glued and taped down a small piece of wood. And then from that wood I have inserted an eye bolt from which I can hang a rope and then a hook made out of stiff wire. These hooks can go over the dividers between your tiles if you have a tile ceiling. If you don't, you might have to install some eye bolts in your ceiling and then hang your model from that. The platform itself should hang at approximately 2 meters off your floor. It also should be level before you start hanging your stars. In order to make the stars to hang from your model, you'll need the following materials. You'll need a set of wooden beads and wooden balls ranging in size from very small beads to balls that are approximately 2 centimeters in diameter. Now, they're colored according to the stellar type that they are. For example, a red star like this one here, this is Ross 154, is just a small bead painted red. I have it on black thread about 2 meters long, and then I have a label attached to it that has some information about it. In this case it says Ross 154, that's its most common name, but it's also known as GJ728. Its spectral type is M3.5V, meaning that it's a medium-sized red dwarf. Its mass is 0.171, that of our Sun, and its distance from us is 9.68 light years. This is Alpha Centauri, which is one of the more tricky ones to do, because it has 3 stars in it, and it has at least 1 exoplanet. The exoplanet is orbiting Alpha Centauri B, which is an orange star slightly smaller than our Sun. The main star in the Alpha Centauri system is Alpha Centauri A. It is a yellow dwarf star, very much like our Sun, but just slightly larger. Then orbiting around those two at a respectable distance is Proxima Centauri, a very small red dwarf. Here is our Sun. Yellow dwarf star. I've labeled it here as Sol, which is the technical Latin name for it. I've also attached 8 different beads, green beads representing the planets orbiting our Sun. Some other stars of interest here. This is Epsilon Indi. It's an orange K-type star, and recently we've discovered 2 brown dwarfs that are orbiting each other, and then that pair is in turn orbiting around the star. This is Procyon, which has a white dwarf orbiting around it. In order to hang the stars accurately, you'll have to use a little bit of trigonometry, including the sine and the cosine functions. My lesson plan explains how to do all of that. Of course, only a few students can hang stars at any one time, or it becomes too crowded. The rest of your students in your class will need to have other activities that they're working on. Now, to help with this, I provided a couple of different activity sheets that can be used. One of them allows the students to calculate the scale and proportion of stars in the model, such as at the scale of 5 centimeters per light year, how big would the entire Milky Way galaxy be if we were to make a model of it? Well, it works out to be about 5 kilometers in diameter, and there would be 200 billion stars in it. It would take several million lifetimes to build such a model. An important part of this activity is to make sure your students understand that there are 2 scales being used. The scale of the size of the stars compared to each other, and then a scale of how far apart the stars are. If we were to actually calculate how big our sun should be in our model, if 1 light year equals 5 centimeters, we do a little calculation and find out that our sun would actually be about the size of a small molecule, say benzene or ethyl alcohol. At the scale of our model, Earth would be about the size of a proton. One of the activities your students can do while they're waiting their turn to hang stars is to create an interstellar voyage proposal. Now, the instructions how to do this are found at the link at the end of this article. We are living somehow far into the future where we have worked out propulsion systems that will allow us to travel over interstellar distances. Now, they can look up on the internet some of the proposals for how we might do that, such as the Bussard ramjet or the Orion project. There are many possible things that people have proposed. What they need to do is create a design for a rocket ship that would carry astronomers and probably their families all the way out to their destination. They also have to plan their pathway through the stars. Which stars will they visit and why? There are areas in our model where there's hardly any stars, other areas where the stars are grouped much more closely together. You have to also propose how you would select your crew and how you would keep them alive for this long voyage. Would you put them in some sort of cryo-sleep and then wake them up when they get to the star system? Or would you have a multi-generational starship? One of the main reasons why I have my students build this 3-dimensional model of the stars is so that they become familiar with the stars in our neighborhood. Instead of something that's mysterious and strange, the stars become their old friends, something that's constant and reliable in a world that often changes every day. I have students tell me before they take my class that they don't enjoy astronomy, that they don't like studying about the stars. I have a hard time understanding that. The more I learn about them, the more awe-inspiring they become. One of the activities I have my students do is to assign a star or 2 stars to each one of the students in my class and have them look up information and write a short report about it. Students can also write about the celestial coordinate system, write ascension, declination, and light years, and how we measure them. Another student could write about how stars are named. There are many different naming systems for stars. One student could talk about stellar classifications, stellar types, how they're identified. Another student could talk about the possibility of life existing somewhere within 15 light years from Earth. And then all of these articles could be compiled together and turned into a newsletter. They could add photos, they could add charts. In the process of doing that, the stars will become familiar to them. They won't be strange, they won't be mysterious anymore. Students could also analyze poetry or literature or art about the stars. They could read short stories. They could also see from that how the stars have become part of our culture. As Robert Frost said in his poem, "Choose Something Like a Star," that we may choose something like a star to stay our minds on and be stayed. I hope you enjoyed doing this activity. If you have any questions, please let me know. I'm David Black. I teach here at Walden School of Liberal Arts. My email address is elementsunearthed@gmail.com. I'd love to hear from you. You can also check out more information about this and other activities we've done at my blog site, spacedoutclass.com. Thank you.